In this video, we're going to learn about Ohm's law, which is a simple mathematical formula that can show the relationship between the voltage, current, and resistance of simple circuits. So even without this formula, we can use two electronic devices, the first of which is called a voltmeter, and the second of which is called an ammeter, and each of these devices is used to measure the voltage around the power supply of a circuit and the current traveling through a circuit respectively. And not surprisingly, a voltmeter measures the voltage and an ammeter measures the number of amps that we have, which is the amount of current. Now, the problem comes with being able to measure resistance, because remember that resistance tells us how much the current is going to slow down. So if we draw the pathway of electrons as they move from the anode through this resistor here, we know that the current is going to be slower on this side because the electrons are moving through a resistor, which is therefore going to slow things down. The problem is that we can only measure current. We can't actually measure the degree by which a resistor slows down the current, and this is why we need the mathematical formula that we call Ohm's law to be able to calculate resistance using the current and the voltage of a circuit that we have provided. Now here we see that the voltage, current, and resistance are actually all given to us, but this allows us to see and determine what the relationship is. So we see that our voltage is 12 volts, our current is 4 amps, and our resistance is 3 ohms. And remember that the symbol for resistance, let me just draw that again, is ohm, which is represented by the Greek letter omega. Now, with these measurements, we can actually see the mathematical relationship that exists between all three of these numbers. For example, let's say that we take the current and resistance and multiply them by together. Well, at this point, everyone should know that 4 times 3 is 12, and it just so happens that this is the voltage of the power supply of this circuit. So here, using these measurements, we have seen that our voltage is equal to the current of the circuit multiplied by the resistance that electrons have as they go through that circuit. Now, let's say we want to find the relationship between voltage and resistance, and we can express them as a fraction like this. So if we take our voltage of 12 volts and divide by our resistance of 3 ohms, 12 divided by 3 is 4, and we see that this is equal to our current. So therefore, current is equal to the voltage of the power supply divided by the resistance that the electrons experience within that circuit. And finally, if we try this last form where we have voltage divided by our current, if we take 12 volts divided by 4 amps, we get 3, because 12 divided by 4 is 3, which is equal to our resistance. So we see that the mathematical relationship between resistance, voltage, and current is that resistance is equal to voltage divided by the current of electrons, or the current showing the rate of electron movement in the circuit. Now, for those of you that are not confident in your mathematical ability, those of you should be freaking out right now thinking, oh dear, we have 3 different equations that we need to memorize, but you actually don't need to remember the each individual form, because using some simple algebra, we can interconvert between all 3 of them. So for example, if we start out with the most commonly used form of the equation, voltage is equal to current times resistance, we can actually convert this formula using simple algebra into the other 2 forms. So let's say, for example, we wanted to convert this from the voltage form and find what the current form of this equation is? Well, that would mean that we need to get rid of the r. Now, if we want to get rid of the r, we see that the r is multiplied by the I here, and we know whenever you do algebra, if you want to cancel a term and move it to the other side, we use the opposite operation. So the opposite of multiplication is division. So here we can see that we have r on the top of this fraction and the bottom of this fraction, and if you have r over r, we have a number divided by itself, which means that if you have the same number on the top and the bottom, this is equal to 1. And whenever we multiply anything by 1, that doesn't change whatever the number is, because any number times 1 is equal to itself. So we can show that dividing by r causes it to cancel itself here, but in algebra, whatever we do to one side, we need to do to the other side. So if we've canceled r by doing this, now we have the current form of our equation. I is equal to v over r. But let's say that we wanted to take the standard form, if you will, of this equation and find the resistance form. Well, then we would need to get rid of I and move I, our current, to the other side, and we can do this the same way because I and R are multiplied by each other. We simply divide by I for the opposite operation, and here we have current over current. Any number over itself is equal to 1, and because multiplying R by 1 is not going to change it, we can cancel the I here, but it's algebra, so whatever we do to one side, we need to do to the other side like this, and that shows us that our resistance is equal to our voltage over our current. So there we have the resistance form. So again, using some fairly simple algebra, we can interconvert between all three different forms. Now, the last part of the video, we're going to do some fairly straightforward calculations using different forms of the equation. So let's write the standard form, V is equal to I times R. Now, in this circuit here, we're given the voltage of our battery and the resistance of a resistor, but we're not told what the current is, so we can use the current form of our equation. So if we want to isolate I, we'll need to divide both sides by R, like so. So we have I, our current, is equal to voltage over resistance. So our voltage is 12 volts and our resistance is 6 ohms. And we know that 12 divided by 6 is 2. So our current is going to be 2 amps. Now here, we're given the opposite situation where we're given the voltage of our power supply and we're given the current of our circuit, which is 6 amps. And now we need to find out what the resistance is so we can manipulate our equation to find the resistance form by isolating R. So we can divide both sides by I, our current. They cancel out, so R is equal to V over I is our starting point, and we have, because these numbers are the same as what we used before, so here our resistance must be equal to 12 volts divided by 6 amps. So here our 12 divided by 6 we know is 2, so our resistance of this resistor is 2 ohms. So again, using some fairly simple algebra, we only need to remember one form of the equation, and as long as we can move variables, we can rearrange the equation to find whatever we need. In the next video, we'll look at how circuits can become more complicated, not just when they have multiple loads within the circuit, but when there are actually multiple circuits technically within the same circuit.